So I'm going to discuss some basic test prep information we need for about 5 minutes. Then I'm going to go over the notes that I sent out to you guys. And the rest of the time is just me going through practice problems. Like I said, I plan on staying on here until about 3 today. I know that's a long time. Um, but we're getting ready for a big test that we've kind of been preparing for all year. So I hope you guys hang out with me the whole time. If not, that's okay. If I don't get a chance to go through everything, I may go ahead and just keep going through problems on a recording after you guys all sign out. I'll upload it later. You guys can keep looking at more. You guys know that you can always hit me up or remind if you have questions. But I'm pretty excited about today. I feel like, you know, uh, after today's review, I mean, you're going to see, you have to see at least 80% of what you're going to see on the exam on there. So this is great. And hopefully you guys got a chance to print out the stuff that I sent to you guys. Because those, you'll want to be able to make notes on there as you go. If you didn't, then maybe you could just take some notes by hand today and then just kind of like print those things out later and attach them together. They'll be great resources to have on hand whenever you guys take your exam. So the first thing I want to go over with you guys today is some exam tips and information. Let me share that with you real quick. All right, so I'll just breeze through this in about 5 minutes. I have not given this to you guys yet, but I will. This is just some stuff I want to encourage you guys to do. This is important. I've had a lot of students telling me that, you know, they're trying to take a test and their parents need the computer or something. So it's really important that you guys, I'm sure you guys have more than just my test next week. I would highly encourage you guys to make a schedule of when all your tests are. Show your parents and your brothers and sisters, everyone else, this is when I'm doing this test. Put it on the refrigerator so that way they can plan their life around these very important tests that you guys have been preparing for all year. You know, you don't want it to come to a point where it's like, well, you're supposed to do this right now. It's like, well, I've got to do a test. This is a big deal. And they may not, sometimes they don't understand how important the test is and what you guys have been planning for. So make a schedule of all the tests you have next week and put it on the fridge and share it with them so they can plan, okay? Um, I hope a lot of you guys have gone through that practice demo. If you haven't, please do it. I've got a link here for you. And you're also going to want to go through the exam day checklist, which I shared with you guys earlier. I'll put a link here if I remember on what that is. You guys should know what that is anyway, but if you don't, I'll put a link here when I share this document with you. On the day of the test, have your notes available in an organized fashion. Have a calculator. Um, they're not going to ask calculator questions, but it's a nice way to check your work and do all the trig stuff that you don't want to have to try to figure out in your mind. Have your cell phone out. Remember, I'm recommending you guys to do your test where you do everything by hand and then just use your cell phone to upload pictures. Do it straight on your cell phone. I think it'll go very easily and nicely. But batteries run out, so have your cell phone plugged in while you're working. Make sure you got a long enough cord and all that good stuff. Have 10 sheets of paper with you with your initials and e-ticket ID in the top left-hand corner before you can begin your test. Before you submit your answers, make sure you number your pages like page 1, page 2, page 3. That is something they want you guys to do. You guys should be getting your e-ticket by tomorrow sometime. They said they'd be sending it out 2 days before your test, so I'm assuming that means tomorrow. Your guys' test is May 11th at 11 a.m., but remember you're checking in 30 minutes early. If you want to see dates of other exams, I put a link here for you guys and you can check it out there. Whatever calculator you're using, please make sure it's set to radians. You'll get everything wrong if it's not, and that's terrible. So make sure that your calculator is set to radians. So everything's FRQ, so let's go through some basics here about FRQs. You want to use clear, specific, and accurate communication. Okay, anything you don't want graded, cross it off. Don't take time to erase it. That's a waste of time. If you write an answer in the wrong spot, just circle it and draw an arrow to where you want it to go. Do not rewrite it. That's a terrible waste of time. Be thoughtful about how much work you show. You know, we've done a lot of problems. Like I said, by the end of the day, and even before today, you guys really should have seen every type of problem pretty much you're going to see. And so you know how to write your answers, right? So be thoughtful about how much work you're showing. If you need to do some scratch work on the side that you know you don't need to include on the test, maybe do it on the side, because if you do something wrong there, it's just going to take up space and be messy. You want to be neat. The people that are grading your test, they're people. And when you're messy, and some of us do have some trouble with having nice handwriting out there, guys. If you're messy, there's a psychological effect there on your graders. Trust me, be neat. They like neat work. But show only as much work as you need to. The work should demonstrate what calculus strategies you use. They should be able to follow your thinking. They don't care about pre-calculus stuff, right? So you don't need to include that. Got to make sure you use the right notation. So if they're talking about a function g of x and you accidentally call it f of x, bad news. So be careful with that. So here's an example of clear and specific. The function f of x is increasing on the interval from 0 to infinity. Here's a bad example. It is increasing on the right side of the graph. Don't write that. You use very specific language there. Make sure that your graphs are labeled with numbered axes. Don't make them guess. Did they mean that dot to be up one? They should see numbered axes, so they should know exactly where you want it to go. If they even ask you to graph anything. Vocabulary, make sure you're using it accurately. Here's an important note. If a question is being asked about a specific function, your answer should be in terms of that function. So if they're asking you, is f concave up? Well, your answer should have to do with f. And you guys know a lot of times f is an integral function of g, right? So you're going to have to talk about g in there, but you're going to have to talk about the relationship that f has with g. So for example, g of x is equal to f prime of x. Show that f of x is concave up on the interval. Here's a good response. Since f is concave up when f double prime is positive and f double prime equals g prime and g prime is positive on that interval, f is concave up. So you are completely relating that all back to f. This one's kind of okay. The problem here is you're not connecting f to g prime though. So it's kind of like you're leaving some open areas. Since g prime is positive, f is concave up. You're still talking about f, but you didn't talk about how they're connected. Here's a terrible answer. You will get no credit for that. Since it's positive, it's concave up. In this case, the its would be the g prime, and this its would be f, but they have no way of knowing that. So make sure you're using very specific language. Units. For any problem that has units or asks you to interpret what something means in the context, your answer should include input units, output units, and the context. And I provide an example here for you guys. Okay. Please, I know that your instinct really wants you guys to do this, but do not simplify things. Just as soon as you've got your equation, you plugged everything in, unless there's some calculus you need to do, like a definite integral, you have to do that. But like if you're just talking like pre-calculus stuff, like plugging like pi into cosine, just leave it after you plug it in. Don't work it out. There's no need to. And you can only go wrong from there. You can't go right. So just leave it. And that's where many students lose their points, by the way. So just take my advice. Practice not finishing the problem. You know what I mean? Just leave it once you got it plugged in. Stop while you're ahead. Don't forget these important theorems here. Intermediate, mean, and L'Hopital. All of those require you to state your answers in very specific ways. I've got it on there. That's also on our notes, by the way, that I sent you. Your exam structure, you guys. Your first question is 25 minutes, then 5 minutes to upload. If I were you on that first question, I wouldn't hedge any bets. Some of you guys are risk takers, but if I were you, I would not wait until, oh, I really want to finish this, so I'm going to give it 1 minute and I'm going to try to upload. I wouldn't. This is a new experience. I would stop right at 25 minutes, and when that 5 minutes is left, I would start uploading your stuff right away. I would start uploading it right away because you never know what you're going to run into. Maybe on the last one you could try to get a little bit riskier, but notice that on section 2 you only have 15 minutes to answer that question. I'm assuming it's going to be a smaller FRQ. They'll probably only have like 3 questions on there, whereas on this first one they'll probably have like 4 or 5. Okay. FRQs, they're 9 points each. They only give whole points, no partial points. Units, if they ever ask for units, please don't leave them out. That's definitely worth some credit. Explanations are worth 1 to 2 points. So if they ask you to explain something, take a shot at it. Don't just ignore it. We've already talked about how much work it shows, so we could skip that. Now, you want to get a 6. That would be nice. And hopefully by doing as many FRQs as we have this year, you guys kind of have an idea of how they grade. Okay, so shoot for 6 points. That's a great score, by the way. I'm pretty sure that's a 4 on the AP exam. Really, you only need 4 to pass, but shoot for 6. There's a saying. It says, shoot for the moon. If you miss, you'll hit the stars, or something like that, right? So shoot for the higher goal, and worst case scenario, you might just get a 3 instead of a 4. But here's the grade breakdown. I know that everybody poo-poos this, guys, but believe it or not, you are biological organisms, and you are subject to the weaknesses and restrictions thereof. Don't ignore this. I know a lot of people do, but you do need to get a good night's sleep. I know you guys have all been pulling the going to bed at 2 a.m. thing. Most of you guys have been. I have been too. And waking up like at 9. Don't do that. Maybe 2 days before, start getting your sleep schedule ready. You want to be awake and ready to go by the time of your test, which is at 11 a.m. Eat a good breakfast. Take care of your bodies. However good your body is, that's how good you'll be. Now, this is important here too, guys. Psychology plays an important role in our performance. Don't give up. Remind yourself that this is for college credit. A lot of people say, I don't really care about the AP exam. But guys, this could save you hundreds of dollars if you pass this test in college. So don't poo-poo it, right? Give it your best. But don't feel defeated. That's very important. This is a tough test. And just remind yourself, when you start to feel like you're not doing well, all I need is 4 points. And 47% is passing. So, and I want to tell you guys, you will see stuff that's going to catch you off guard. You're not going to get on there and be like, oh, I know all of this. That's not going to happen. Just like every FRQ I've been giving you guys for the past few weeks, you will come across something you're like, what? It's okay. Remember, you need 4 points out of 9, okay? So don't get defeated. It is a tough test. Who knows? Maybe it'll be easier this year because they're trying to be nice over the COVID thing. I have no idea, though. So now, by the way, if you guys finish early, probably not, but if you do, I would really encourage you guys, if you have like a couple minutes extra between each test, I would get up and do some jumping jacks. I know that sounds stupid, but think about it. You're a biological organism. Your brain works based on oxygen delivery, right? So if you're sitting there and staring at a computer for, 30 minutes, your brain is losing oxygen. So if you get up, do some exercise, you're getting oxygen in your brain, I guarantee you'll be thinking better for part 2. So in between part 1 and 2, seriously, I know it sounds stupid, sounds ridiculous, get up and do some jumping jacks for about 3 minutes. Get your heart rate up and get going for the next part, if you get time. Okay, so those are my suggestions. I'll upload that for you guys. And now what I'm going to do is I'm going to go through real quickly with you guys the notes that I shared with you. And if I were you, as we go through this, just add some other little tidbits on there that you may feel are useful. Just a second here. Let me open it up. Right. Okay. Trying to keep this stuff short because I really want to spend most of our time on going through the questions. But this thing is organized, guys, by FRQ types that you're going to see that are pretty common. I guarantee you're going to see at least you're going to see all of these on here at some point. So you're going to have a table question. Okay, table questions almost always require a left, right, mid, or trap Riemann sum. So I'll review those with you guys in a minute. Sometimes it'll ask you, does it give an overestimate or an underestimate? It'll ask about average rates of change, maybe estimating f prime. That's a very common one. This one's not, you might not have to worry about this too much, but there is a difference between integrating f as opposed to integrating f prime. Units, they're going to ask about units on these problems. You need to understand how units play a role when you're taking integrals and derivatives. Also, mean value theorem and IVT come up on the table questions. So that's one type of question you look at. I'll go through those details in a second. I'm very certain that one of your questions this year are going to be a differential equation. I'm pretty sure of it. So I would definitely know this one well. So here's all the parts of a differential equation question. And this is the third major type, where they give you a graph and an integral function. We've done all of these repeatedly. So those are your three major types of questions you could be asked. Now, on this worksheet, I've also included types of questions or pieces that may pop up in each one. It's possible you'll see a related rate. Symbolic differentiation, you probably will see that. It'll probably be like a part of one of the questions. So we'll talk about that. L'Hopital, I'm sure they'll sneak that in there because limits are technically an important idea, but there's really no good FRQs for limits except for L'Hopital. So there's a good chance they're going to sneak that in there somewhere. Piecewise functions, we looked at a few of those on last week's homework. You might see that. We'll kind of brush through that real quick. So those are some common things that could pop up. But you have your three major types of FRQs here. So real quick on working with left Riemann sum. So if you guys are asked to do a left Riemann sum, you guys know that you leave out what you do is you calculate the distance between the x values, right? And this is where you guys can start taking notes if you want to. And that represents the base of your rectangle, right? And on a left Riemann sum, we don't use the last point on the right. This is my height, so it's height times base, height times base, height times base, height times base. And that's a left Riemann sum, okay? For a right Riemann sum, it's the same thing. You find all your bases, but you cross off the left point, and it's base times height, base times height, base times height, base times height. And honestly, at that point, once you write out that sentence, like 9 times 1 plus 8 times 1 times and plus 7 times 1, etc., leave it. Don't work it out. It's pointless. Don't do it. Just leave it. Okay? Let's take a look at a midpoint. Midpoint sums are interesting. So midpoint sums require you to skip. So like I would be going from 1 to 3. And the base of that rectangle, therefore, would be 2. The height is the one in the middle, though. So the height of the rectangle would be 6. So it's 6 times 2. The next one would be from 3 to 5, which is also 2, and that height would be 8. So when you do a midpoint, you have to skip pieces to get that. So that's that one. And once again, I'm recording this, so if I'm going too fast for you guys' notes, just put a star next to it and you can come watch the video later. As for trapezoid sums, these distances, we still want to find them, but we're actually going to call those the heights this time. Those are the heights. And these numbers are the bases. So my first trapezoid has a base of 5 on one side and a base of 6 on the other. And then it has a height on the bottom of 1. And the formula is 1/2 times the height times the sum of the bases plus. And then you do it again. Here's 1/2 times the next height times the sum of the bases plus, and you just keep going. And once again, I would not take the time to work that out. Once I wrote out that whole long numbered sentence of adding together all those trapezoids, I would just leave it. Okay? Let's go ahead and keep going here. What about overestimates or underestimates? When it comes to those, you guys remember that I gave you guys a little bit of a chart here. Honestly, I would just draw a picture, but it's basically based on two things. It's based on whether your function is increasing or decreasing, and whether you're doing a right-hand sum or a left-hand sum. So increasing, decreasing, right? Now, if you're doing a right-hand sum, you're starting on the right. all your rectangles will be over, so that's an overestimate. But on a decrease, if you're starting on the right, all your rectangles will be under the curve, right? So I didn't memorize this. I'm just figuring this out as I go. You can literally just sketch it, and I see a few of you guys doing that. But if you want to write this down in your notes, you can. So for a left-hand sum, increasing will be an underestimate. And for a decreasing, a left hand will be an overestimate. So you could tell by the picture whether it gives an overestimate or an underestimate. Okay. Average rates of change are very common. A lot of times, average rates of change are just a way of estimating an instantaneous rate of change. So I'm just going to put these two ideas together here. The instantaneous rate of change is approximately equal to the average rate of change. And just remember that when you're doing an estimate of an instantaneous rate of change, you're basically just picking the 2 points that are closest to the point you're trying to estimate. Okay. If you're integrating the function that's actually in the table, then that's a Riemann sum. Okay, so if you're actually trying to integrate a function, you're doing a Riemann sum. And the clue for that, by the way, is they're going to tell you, do a trapezoid or do a midpoint. But if you see that you're integrating the derivative of what's in the table, well, when you do that, you're actually just going to apply the first fundamental theorem of calculus, where you just do this. So if you're integrating a derivative, you get the antiderivative, which is f, and you just have b and a. So basically, you're literally just plugging in two numbers from the table and subtracting. So that's another common question for tables. Let's keep going here. Units. So let's say that the units for f is dogs. Okay, let's just say we're talking about this function f, and it's talking about dogs. Okay, well, whenever you take a derivative of a function, it's usually with respect to time. So it becomes dogs over whatever time you're talking about. So when you take a derivative, you're dividing by a time factor. Okay, so it could be like dogs per minute or dogs per second. A good way to help you with that is the other way we write derivatives is like this, right? df dt. So whatever the unit is for f and whatever the unit is on the bottom, those are your units, right? If you take a second derivative, then you're dividing by time again. So that would be dogs per time squared. Okay? Now, whenever you integrate, what happens is you do the opposite of dividing by a time unit. You multiply a time unit. So if you were to integrate the f, you get a really weird unit out of this. You get dogs time. And that was actually on this last week's homework FRQ. I forget what it was. Wasn't it car? It was vehicles, right? If you integrated that vehicle function, the unit for vehicles was just vehicles, right? And when you integrate it, you get seconds. So the answer was whatever the answer was, like, let's say 10. It was 10 vehicle seconds. Whatever that even means, honestly, I couldn't tell you. What helps this make a little bit more sense, though, is let's say that what you're starting off with, let's say that f, let's say it's not dogs, let's say it's miles per hour instead, okay? Well, if you integrate it, you're multiplying by time, right? So the time on the bottom goes away. So if f is miles per hour and you integrate it, it just becomes miles, okay? So the point here is that derivatives divide a time unit in, integrals multiply a time unit in, okay? So keep that in mind as you're working through the problems. Mean value theorem. You guys know that when you're doing mean value theorem, they're asking you if something exists for a derivative. If they're asking if something exists for the function itself, that's IVT. Okay? And you guys know how to write this, hopefully, right? You say, I have very little space, so I'm trying to write up here, but for MVT, you would say since F is continuous on AB and differentiable on AB, there exists a C such that, and then after that, you do your little formula. Sorry, my handwriting's so messy. It's kind of hard to write on my computer screen. But that's for MVT. For IVT, it's since F is continuous and goes from y equals L to y equals K, there is a C such that F of C equals whatever y value they want you to do. So those are the two types of theorems there. Now MVT and IVT can both appear in any of the FRQs that we looked at: table questions, differential equations, or the last one, which was graph questions. So these questions are very dynamic. These two, they can actually appear in anything, but that's kind of how you state them. And how do you know when to use which one? Because they kind of look the same. It's all about, are they asking about, does a certain derivative exist, or does a certain y value exist? If it's a derivative value, that's MVT. If it's a y value they're looking for, that's IVT. And this is how you word it. Okay? And I know I'm talking kind of fast, but like I said, I don't want to spend too long on just going over these notes. I want most of our time to be practice problems. But for differential equations, here's all the types of questions that you could possibly expect to see. And these are big. And my favorite one, as I've told you guys many times, is this first one here, finding a particular solution. Okay, I've shown you the points here. The reason this is my favorite one, you guys, is because if you see a differential equation question on your test, chances are, if you do that one question and skip the rest, you already passed that FRQ. So this one is just worth so many points. I've emphasized it a lot. Really worth your time. Really worth your time. And the cool thing about these is the hardest part is the last one usually, because it requires a little bit of creativity. But by then you've already got a 4 out of 9. I mean, it's amazing, even if you don't get that last point. You'll definitely see this on a differential equation test. They almost always ask you to find a tangent line and then to use that to approximate a y value. So I'm not going to go through those. I'm just putting the steps here for you guys. Let's take a look at some more here. Sometimes, not very often, but sometimes they will ask you to do the second derivative. And usually that's an implicit thing. So like, for instance, they usually give you like a function's derivative. Excuse me. Like take this, for instance, right? Well, if you take the derivative of that, don't forget that when you take the derivative of the y part, you're going to get a y prime. And when you get a y prime, you're usually going to have to replace y prime with what y prime is. And y prime is 2y over 2x. So don't forget, when you do implicit differentiation, you always get a y prime when you take the derivative of y. And sometimes you'll have to back substitute it in. Concavity. So you guys know that hopefully by now that if f double prime is greater than 0, that means concave up. And if f double prime is less than 0, that's concave down. Okay? So just a restatement there. And if your graph is concave up, then a tangent line, like if you have a concave up function, then your tangent line is an underestimate. sometimes they'll ask you, after they've done a tangent line approximation, they'll say, well, is this an underestimate or an overestimate? So what they're low-key asking you to do is that they're asking you to find the second derivative and find out if it's positive or negative. If it's positive and it's concave up, that means your tangent line is an underestimate. If it's negative and concave down, that means it's an overestimate. Okay? Sometimes they'll ask you to sketch slope fields. You guys are all pretty good at that. I'm not too worried about it. Just know what they're looking for there. They really want to make sure you have the zero slopes in the right spot. And they really want to make sure that if a slope's positive, it's going in the positive direction. If it's negative, it's going in the negative direction. If you get those things right, then you're good. They're pretty easy about that. I doubt they're going to do either one of these, though, to tell you the truth. The reason I don't think they're going to do either one of these types of questions is because it would require you to draw a really complicated graph, and they know that you have limited time. So taking the time to do is, and these things, they're always worth like one measly point. So honestly, I highly doubt they're even going to ask you to do those. They usually do, but on this test, I highly doubt it, because by the time you drew the graph, you would have spent like 5 minutes, and all that's just for one stinking little point. So I highly doubt they're going to ask it, but it's a possibility. And you guys are pretty good at them anyway, so I'm not too worried about it. So that's the second big type of question. So we have table questions, we have differential equation type questions, and then we have these graph questions. So that's the one where they give you a graph, and then they say at the bottom that the graph is a graph of g. And then they tell you about this new function f, which is the integral of g. And almost always, you're going to end up doing geometry to find the area under the curve. So on these types of questions, they may ask you to find one of three things. They'll ask you to find the f value, f prime value, or an f double prime value. If they ask you to find the f value, that's literally just going to be an area under the curve. So, have your geometry ready, finding areas of squares and semicircles and all that good stuff. If they ask you to find f prime, that's just a g value. In other words, if f is the integral of g, then f prime is g. And that means if they're asking you to find what's g of 2, they're asking you to find literally what's the y value on the g graph at that point. So that's really easy. If they're asking for f double prime, well, that would be the derivative of g, which represents the slope of the g function. And a lot of times all you have to do is count your rise and run and you got it. So it's pretty simple. Just be careful with your signs, positive slopes, right? And versus negative slopes. So I noticed when we had a question like that on our FRQs, a lot of people forgot to make the slope negative when it was supposed to be negative. All right. This question, they may ask you guys to find a relative max or a relative min. So what you're going to do is you're going to find basically where does the g graph touch the x-axis? And if it's going from positive to negative, that's a relative max. If it's going from negative to positive, that's a relative min. And up here, basically, I'm kind of giving you guys a hint about how to write that. Remember, you have to say f has a relative max at x equals 2 because f prime, which equals g, goes from positive to negative at that point, right? So we practiced writing that a ton of times. But there's that one. Same thing for relative mins. If they ask you guys to find absolute extrema, that's the candidates test. Done that a lot of times. The concavity of f is based on f double prime, which as you guys know is g prime, which is just the slope of g. So if you guys see where the g function has a positive slope, that means the f function is concave up. If the g function has a negative slope, that means that the f function is concave down. They may ask questions about where f is increasing or decreasing. Well, whether f is increasing or decreasing is based on f prime, which is g. So anywhere that g is above or below the x-axis, we'll answer that question. So if g is above, that means that f prime is positive, which means that f is increasing. If g is below the x-axis, that means that f prime is negative, which means it's decreasing. And I just want to warn you guys, be careful. I'm using f and g here, right? But on your test, they could switch the roles. They could say that the graph is f and the integral function is g. So you got to make sure you're paying attention to how they're using the names of the functions. How can you find where points of inflection are? F double prime equals 0 and changes signs. Or you can say F double prime is undefined too. So anywhere where, remember, F double prime is the slope of G, right? So in other words, where G crosses the x-axis, I'm sorry, I take that back. That's not correct. So where G has a 0 slope, like for instance at the top of a curve or at the bottom of a curve, those are places where you might have a point of inflection or where G has a cusp. Okay, so whether you're at the bottom of a smooth curve or at the top of a smooth curve or at the top of a cusp or bottom of a cusp, you guys notice how the slope is changing? So that means that G prime, the slope of G, is changing at that point. So you can find a point of inflection anytime F double prime equals 0 is undefined, or in other words, where G prime is 0 or undefined, and that happens at the bottom of cusps and curves. Okay, but it only applies if the slope actually changes at that point. All right, related rate questions. We've done a lot of these. I've included the steps here for you guys. We won't go through it right now, but it's there for you guys. Symbolic differentiation. You guys might not know what I mean by that, but a lot of times they give you stuff like this, right? H of x is equal to f of x over g of x, right? And then they'll say find h prime of 2. Well, what you do is you find the derivative first, right? You do low d high minus high d low, draw a line, square below. That's first. And after that, you plug in the number and solve. Okay, so you'll probably see one on your test. I'm not sure, but it's possible. Those are pretty common. L'Hopital, I've got the steps there for you guys. How can you tell if a piecewise function is continuous? I've got the steps there. How can you tell if it's differentiable? I've got the steps there. And I think last week on our homework, if you guys did it, you have to find missing values, like find the value for k. I've got the steps there. Whether you want to make it continuous or differentiable. So we'll probably get a chance to practice all those. But there's all of our notes. And so now what I'd like to do for the rest of our time, guys, is go through practice problems. I figure what we'll do is we'll take a break at every hour. So like at 1 o'clock, we'll just, if you guys don't mind, we'll take like a 5-minute break so you can go to the bathroom, get a drink. And then I'll come back at 1:05 and we'll pick up again. So let's work on some math for about 15 minutes and then we'll take a break. All right, let me bring up a new sheet for you guys. Look at our sample FRQs. And once again, hopefully you guys printed these out. And that way we can kind of make some notes on there as we go. All right, so there's our first one. Whew, my voice is killing me. I've been talking a lot. So, I mean, I could go through this pretty quick, but I think what I'm going to do, guys, is kind of try to make this a little bit more interactive than just me talking. I want to give you guys an opportunity to think. Now, by me doing it that way, that's going to slow things down. But like I said, if I don't get through most of the major stuff, I'll just finish the rest of it on a video and I'll upload it later. And you guys can watch it on your own time, okay? And some of you guys have come in a little bit late. That's okay. I am recording this, and you guys can watch it later. And hello. But unfortunately, I mean, I love having the 15 of you guys who are here, but I've got like 50 calculus students. So Mr. Beta is a little sad right now that I'm missing so many people on such an important study day. But that's okay. We'll record it, and we'll hope by faith that these people are going to watch it later. All right. So let's go ahead and take a look at this, you guys. So part of your job is going to be to take those notes that I just went through with you guys and try to figure out where we're at. So first of all, here's my first question to you guys. And I think what I'll do is I will just I'll just call on somebody. But my first question to you guys is, what does this look like to you? What, out of our three types of questions, does this look like a table question, a differential equation question, or a graph with integral function one? Oh, as soon as I said I was going to ask questions, somebody left. That's cute. All right. How about Zarina? What type of FRQ question is this? Got it. So when you guys are taking your test on Tuesday, you can identify what type of question it is. You're going to take those notes that you printed out. You're going to flip to that page and have that right out on top. Don't start studying it. That's a waste of time. But just have it out and ready as you go through this question, okay? So you all know now to bust that out. Now let's take a look at this first question here. We just went through some of this stuff. How do we, well, let's read it. That's kind of important. We want to read what we're doing here. It says, let f be a function defined on the closed interval from -2 to 6. The graph of f, consisting of the 5 line segments, is shown at the right. And then here's our integral function here. Now the question is asking us to find g of 2. So I'm going to ask a question out there. I'm going to ask, let's do Ashley. Ashley, how do you find g of 2? I'm getting crickets there, Ashley. Okay. Not sure if Ashley hears me. So I'll open it. Go ahead. How do you do it? Hello? Yeah, please. I don't know who that is, but go ahead. No, no, no. So let's write it out. G is going to be area under the curve. G prime. If you take the derivative of G, what do you get, you guys? You just get F. And so that's just a Y value. And G double prime will tell you F prime, which is the slope. Now, some of you guys might be confused because you're looking at the sheet I gave you and you're getting confused by the F and the G. But look at the difference here. The G is out here, the F is in here. On my sheet, they're reversed, so you got to be careful with that. So to find G of 2, I'm going to be finding the area under the curve from -1 to 2. So let's do that really quick. So from -1, that's here, to 2. How would you write that on your exam? You would have to do this first, okay? They would want to see this on your exam. They would want to see you set it up. And at that point, I'm pretty sure they don't care about any more math that you show. You're good just to put the answer because I think they would assume that most calculus students can do that in their head. So what's the area of this triangle here? Got it, good. And then this one is 2 times 1, which is 2 cut in half is 1. Notice this one's negative because it's under the curve. So the answer for this one would be -2. That's how you would write your answer on your test. I'm pretty sure that would be worth 1 point. Okay? Now let's do G prime. Now G prime is what you get when you take the derivative of this. And if you take the derivative of this side, the integral goes away. So G prime of 2 is f of 2. So all they really want is the y value of the graph at that point, which is what? There you go. And guys, don't be afraid to ask questions here. So please feel free to ask. But this is how you would show your work there. G prime of 2 is equal to f of 2, which is just 1. That's it. That's all you need to show. Okay. Notice that since they're asking about G, right, I'm going to reference G. But I know that I need to talk about F to get my answer. So I show the rest of my work there. So that's kind of how you show your work. All right, let's take a look at another one here. Find the average rate of change of G on the interval. So take about a couple seconds. If you already know, awesome. But I'll give you a couple seconds to kind of ponder that, look at your sheets. I'm going to call on somebody to tell me what to write. All right, so I'm going to ask Andy. Andy, how do I find the average rate of change of G on that interval? Very good. So that's the first thing you'd want to write. Um, I think this would probably be a 1 point question. I'm not sure. If it was a 2 point question, this would be worth 1 point itself. But we do now we can't just leave it like this. The reason we can't is because to figure out what these are, you have to do calculus. If you have to do calculus, you need to do the work. If you need to do basic math, you don't need to do the work. But G of 6, that's actually a calculus question. How do I find G of 6? Juliana, how do I find G of 6? What do I do? Find the area under the curve, right? So from -1 to 6, we need to find the area. So from -1 all the way up to 6. That's just basically 2 triangles. We already did this one earlier. That's -3. And this one is 1, 2, 3, 4, 5. So 5 times 2 is 10. Cut in half is 5. So what does G of 6 equal? 2. 6 take away 0 is 6. Now we need to do G of 0. So that means we're going to find the area from -1 to 0. We already know that. It's -3. Now at this point, you could leave your answer. You could be done, right? I mean, this isn't too hard to simplify, so you're probably not going to get that wrong. But technically, you could have just left it like that because now the calculus is done. All right? Let's move on to another question. All right. Find the x-coordinate of any point of inflection of G on the interval from -2 to 2. So look at your sheets, take a minute. How do you find points of inflection? And then I'll call on somebody. All right, what do you think, Brandon? Perfect. Very good. On our little sheet, we talked about how the point of inflection, well, to get kind of detailed here, well, I'm just going to keep it simple. Exactly what Brandon said. basically the point of inflection for these graphs is basically going to be at the peaks or the troughs of the curve, at either a cusp or at the smooth turning points. So there it is. But now how do we write this? This is important how you write it. So how you would write that is you would say there's a point of inflection at x equals -1 and x equals 4 since, now what function are they asking about in the problem? They're asking about g, right? So I need to start with that. So since g double prime, okay, that's when we're talking about points of inflection, that's where the second derivative of g is, right? Since g double prime, which equals, now I'm going to transition to talking about my graph. That's f, right? So g double prime is equal to f prime, right? And I would put changes signs at those points. So, having some interesting technology stuff here. There we go. Okay. So, this is g. The first derivative is f. The second derivative is f prime. And f prime is the slope of this graph. So g double prime is equal to f prime, which is the slope of our graph. And the slope changes at those points. It goes from a negative to a positive slope, and it goes from a positive to a negative. Now, for points of inflection, you don't need to waste time saying it goes from negative to positive or it goes from positive to negative, because the point is, all it matters is that it's changing. Now, if you're talking about relative extrema, you do have to say whether it's going from positive to negative, because that determines whether it's a max or a min. But for points of inflection, all you need to do is say it changes, and you can save yourself some time that way. All right. We'll do one more question, and then we'll take a break, okay? Let's go ahead and take a look at part D. Find the absolute minimum value of g on the interval from -2 to 6. So this one, I'm going to just call on somebody right away. Let me ask Christian. Christian, how do you find an absolute minimum? What do you do? You can't. Is that Jennifer? Yeah, I can't see anybody's face. All I hear is voices. So, yeah, go ahead, Jennifer. What do you think? Great, good job. And by the way, some people were confused when I assigned this as homework over the past few weeks. It says explain your reasoning. The If you show that little table, that's your explanation. So that counts, just so you guys know. So you don't really need to get too wordy with these ones. So here we go. Let's do what Jennifer said. It's the candidates test, basically. So now let me ask this. We're trying to find the absolute minimum of what? Of what function? The g function, right? So that's what we're going to put right here. And like Jennifer said, we're going to do the endpoints and the critical values. So my endpoints are the -2 and the 6. Now, here's a question, and I'll give you guys some think time. This one's not on your sheet, so I'm just kind of asking you guys to remember this. But how do you find, or I don't, maybe it is on your sheet. I don't remember if I put it there. But you need to put your critical values in there. So my question is, how do you find the critical values? Let me ask somebody. Take a minute and think about it. How do you find the critical values? Let's try Thea. How do you find critical values? No, it's not. That is That would be for finding points of inflection, though, and those are very common to get mixed up. But we're looking for critical values, so let's try a different answer there. Someone else think they know how to find critical values? Very good. So let's talk about why that is. So now, Thea, the reason why that we mix that up a lot is because it's not the slope of our graph, but it could be, you could technically say it's the slope of g. Critical values are where the function you're talking about are where its derivative is 0 or undefined. But the derivative of g is f. So if g prime is 0 or undefined, then that means we're looking for where f is 0 or undefined. And that happens whenever the f function crosses the x-axis. Now, you don't have to say any of that in your answer to this question. So just memorize it. The critical values are where the graph touches the x-axis. And so we could have saved a lot of time if we just had that fact memorized, and we could just put in there right away, 0 and 5. Boom. So now I've got my endpoints, I've got my critical values, and now we just need to figure some stuff out. And most of the time, guys, when they ask this question, you should have already found out some of these values. They deliberately set the question up like that to save time for you. Like, for instance, we already found g of 0 and g of 6 earlier. We found out on question number, or part B, we found out that g of 0 was -3. And we also found out on part B that g of 6 was 2. Correct me if I'm wrong. Oh no, I'm sorry. G of, was it g of 6? Oh, you know what, guys? You know what I'm realizing? That's 5, right? So that's g of 5. So going from here to here, that's 5 and -3, right? That one's 2. But you know what that makes me realize is that we did part B a little bit wrong. So I'm going to go back and fix B after our break. I'll talk about it with you guys. But for now, I'm going to leave it like that. But now let's go ahead and do the other two here. Let's do g of -2 and g of 6. And what I'll do is I'll just kind of pause here for a second, let you guys calculate those. And then I'll call on you guys to share out your answers. What is g of -2 and g of 6? We're a little over schedule here, but I'll still give you a 5-minute break in a minute. Finish this one up first. No. Check it out. There's two weird things about this. First of all, there's actually two shapes you need to deal with, right? A rectangle and a triangle. But keep in mind, we're starting at -1, right? So you're going backwards. That kind of matters. So that one is a tricky one. G of 6 is a little bit more chill. All right, does anybody think they got some answers out? You can start shouting them out if you know them. I don't think so. That's not what I got. I don't think so. That's not what I got. Ooh, that's not what I got either. All right, let's work it out. Let's see who's right. Maybe I'm wrong. So our integral for g goes from -1 to -2, right? What's wrong with that? We got to flip it. And when we flip it, what do? Yeah, good enthusiastic answer. Yes, very good. And so we have that, right? Now, this part here represents the area under the curve. Let's see what that is. This piece here is -2, right? And so is this piece. So whoever said -4, you weren't doing your geometry wrong, but you were missing some calculus stuff. Because if this is negative on the outside here, and the area under that piece is -4, then that comes out to be 4. So who said 4? Because you were right and I was wrong. Nice job, Ryan. So g of -2 is actually 4. Very good. All right. Now let's do the other one. The other one's not quite as bad. What's the other one? Anybody get it? Yes, 1.5. The reason for that is because um, we're going from -3 all the way up to here and then here also, right? So we have -3 plus 5 minus a half, because that's a -1/2 down there, right? So that's 2 take away 0.5, which is 1.5. Okay, now the question was asking us what's the absolute min? You just pick the smallest number, which I know you guys know that, so the answer is that. So I would just do this, absolute min, and that is all you need for an explanation. You just need this table, and you need this. And I think a lot of times these are worth some good amount of points. How I've been doing it, because I think I've seen them do it this way before, is they give 1 point for your candidates being correct, 1 point for the correct y values, and 1 point for correctly identifying the extrema. So there you go. Cool. So what I'd like to do is I'd like to take a break. You guys need to go use a restroom. I'm gonna go get something to drink for my throat here, and I'll be back in about 5 minutes, and we'll keep going. But before we do, I'm gonna fix something on part B when we get back because I made a boo boo. All right. So go ahead and take a break, stretch your legs, and we'll be back. About 5 minutes. About 1:15ish. Okay, guys, I think we'll continue then. Um, so I was saying that I need to go back and fix something that I did wrong on part B. On part B we had this, and I don't think I actually did g of 6 correctly. We did g of 0 fine. G of 0 was -3. But g of 6, I accidentally stopped at 5. I didn't go far enough. So that one was actually supposed to be, I think Ryan was saying it was like 1.5 earlier. So if you want to fix your answer for that on part B, that would probably be a good thing to do. All right, let's continue our discussion here. So part E says find g double prime of 2 and determine the concavity at that point. So I'm going to call on somebody there. Maya, how do I find g double prime? What is g double prime equal to? Like, what does it represent? Beautiful. I love that. It was a complete answer. That was perfect. So if I look at my graph here, what is the slope at 2? Well, all you have to do is look at your rise and run, right? It goes over 2 and up 1. You do want to be careful, though, to be paying attention to the direction. It's a positive slope. So the answer is, here's how you'd write your answer. since g double prime equals f prime, g double prime of 2 is equal to 1/2. We have a half slope, and it's a positive slope because it's going up. So that's how you'd write your answer there. But we're still not quite done because it wants us to talk about the concavity. So we would say, therefore, g is what at that point? What does that tell us about g if g double prime is a positive half? Anybody can chime in on that if you want. Beautiful. That's probably good enough to write, but to be safe, we could say, since g double prime of 2 is greater than 0, but I mean, that's kind of said over here, right? So probably not necessary to write this second part. Excuse me. All right, that's the end of that one. Let's see. On what interval is g concave up and decreasing? So we just answered the first part, like, how do you know when g is concave up? G is concave up when g double prime, which equals f prime, is greater than 0. In other words, anywhere on this graph where I have a positive slope, this g would be concave up. So that would be here and here. So on those two intervals there, from -1 to 0, and then from 0 to 4, we could say that g is concave up. Now, where is g decreasing? We could say that g decreases when what? So think about it for a second, and I'll call on you to share out your answer. When does g decrease? What do you think, Caitlin? When does g decrease? So kind of like, I'm going for something kind of like this over here. Like g is concave up when what? Well, g is decreasing when g prime is less than 0, right? Or I guess we could say when g prime, which is equal to f, is less than 0. Now, when is f less than 0? F is less than 0 anytime on this graph over here, it's below the x-axis. So, for instance, like right here, oops, fix that real quick. From here to here and over here, that's when f, which is g prime, is less than 0. So we're looking for the part of the graph where it's green and red, where it's below the x-axis and increasing, and that would be right here. So the interval we're looking for is from -1 to 0. I think these might be good enough for your explanation, just stating those two facts. So you could put since g is concave up when g double prime is greater than 0, and since g decreases when g prime is less than 0, you could say g is concave up and decreasing on that interval there. But you may not need to add this little statement here. This is probably good enough, just these three things. All right. Let's go ahead and take a look at part H. So define h of x as this, Determine if there's a relative min or max or neither for h at x equals 2. Justify your answer. Okay, so this is a little bit of a higher level type of question here. What did I call this on our study sheet today? Does anybody remember what I called this type of expression? When you're being asked to find a derivative, something like that? Yeah, there you go. Symbolic derivative. So if you didn't know that, on your little notes here today, I draw a little arrow that and put symbolic derivative. Okay, so and why we're calling that is because we don't really know what the function is, but we're looking at it in terms of symbols. So that's why I call it symbolic. So determine if there's a relative min, max, or neither. Now, how do you know how to find a relative min or a max? Well, um, there's a few ways to do it. You could do um, the first derivative test or the second derivative test. Now this is not on your sheet. The first derivative test kind of is on your notes that I gave you. The second derivative test is not. But I'm actually going to use the second derivative to do this one. I'll explain what the first derivative test is, but on this problem, I think the second derivative test is easier. So what is the first derivative test? Well, that's where you find the critical values and you put them on a number line. I'll put CB. And what you do is you find out what your slope is in between. And if you know what your slope is, you can kind of tell whether points are maxes or mins. Okay, that's the first derivative test. The second derivative test is a little bit different. The second derivative test is where you find your critical values still, right? But instead of doing this, what you do is you take your second derivative and you plug your critical values in there, okay? So if at your critical value you end up with a positive number, like greater than 0, that means it's concave up, and that would make it a relative min. If you plug your critical value into the second derivative and you get a negative number, that means your graph is concave down and your critical value would be a relative max. So that's the second derivative test. It's pretty rare actually to use the second derivative test. But when I was putting together these questions, I wanted to make sure I put questions that were all from the notes that I gave you. But I also wanted to keep some of the things that were originally in the original problems because I've kind of manipulated these a little bit just to kind of show you, you will come across things that tweak your eyebrows once in a while. They're not all going to be straightforward. So on this one, we are going to use the second derivative test, even though it's not that common. So let's go ahead and do that. So how do you do a symbolic derivative? Well, if you look at your notes that I gave you, the first thing you do is you find the derivative. So I'm going to ask somebody here, what derivative rule do I apply to this? Let's ask Neha. Neha, what derivative rule do I apply to this expression here to find h prime? Oh, maybe I'm getting a cat there. Good. Yeah. Okay. So Neha responded on the group chat. Yeah. So it's the product rule is what we call it. And so um, I think I'm getting a little ahead of myself here. So we want to find critical values, right, you guys? So if you want to find critical values, then that means you have to find where the derivative equals 0 or is undefined. So we have to find the derivative of h, which Neha has told us is the product rule. So h prime will be equal to blank, blank, plus blank, blank. So product rule is take the derivative of the first piece, do nothing with the second piece, plus do nothing with the first piece, so we'll just leave that as x, do the derivative of the second piece. Okay, Now we want to know what is, where does this thing equal 0? Oh, well, they're asking us. They want to know, is that a relative minimum or a relative maximum? So in other words, if this thing is a relative min or a max, then when I plug in 2 here, I should get either 0 or undefined. So let's see if that actually works here first. So g of 2, I think we found that earlier. What did we find out g of 2 was? I think it was -2. So this piece here is -2. Then we have plus. And then g prime of 2, we found that also. G prime of 2 was a half, wasn't it? G prime of 2 was 1/2. Okay. I think that's right. Oh, hold on a minute. I may be brain porting. Hold on. Oh, you're right. You're right. So this is not half. Thank you. All right, so I'm going to erase that. I was looking at the slope of the line, you guys, is what Ryan was saying, and Andy. And the slope of the line is g double prime, but that's not what we want, right? We just want g prime, which is the f value at that point. So g prime of 2 is f of 2. In other words, they just want the y value. So that was my mistake there. So they're right. That's supposed to be 1, and that makes 0, right? So far, this is looking good. It could be a relative min or a relative max because that's where the derivative equals 0. But now I want to know, is it a min, max, or neither? The way that we're going to answer that is by finding the second derivative of h. So let's do that. Okay. So first of all, if I want to find the second derivative, take the derivative of that. That's going to be g prime, right? Plus, and now we have another product rule here, right? We've got something times g prime. So blank, blank, plus blank, blank. So take the derivative of the first piece and do nothing with the second piece. Then do nothing with the first piece and take the derivative of the second piece. So there's that. And now I'm going to go through and plug in 2 for all the x's. Now, if I end up with a positive answer, that means that it's concave up. And if it's concave up, that would make it a relative min at that point. If I come up with a negative answer, it's the opposite. So let's see what we get. And like I said, this is the second derivative test. You could do the first derivative test. I just think it's a little bit harder and takes a little bit more work. And this one just so happens that it's easier. So g prime of 2. G prime of 2 is f, right? So g prime of 2 is equal to f of 2, and f of 2 is 1. So we know that this piece right here is 1. I'm going to put that there. Now we want g of 2. G of 2 is what you would get if you took 2 and just plugged it right here in. So we want the area from -1 to 2. And we found that earlier. It was -2. So this piece right here is -2 plus 2 times g double prime of 2. G double prime of 2 is equal to f prime of 2, which is the slope of the graph at 2, which we said earlier was a half. So let's figure this out. 1 take away 2 is -1, and 2 times a half is 1. Those two things come together to make 1, actually 0. And so at that point, it looks like it's inconclusive. If it's positive, it's concave up. If it's negative, then it's concave down. But we got 0, so unfortunately that's inconclusive. Now that could mean either that it's neither, or it could mean that it is the second derivative test just failed us. All right, so when I did this earlier, I thought it worked out, and so now it doesn't. So I hate to do this, but it looks like maybe I will go with the first derivative test here on this. Sorry. So back to first derivative test. What was our critical value? We're testing 2, right? So let's find out what g prime of 2 is on the, or h prime of 2. We're talking about h right now. Let's find out what h prime of 2 is to the left and right of that. And you're going to want to pick some points that we can actually work with. So like, you can't pick a cusp. Don't want to deal with that. We'll go like right here though. We'll pick those halfway points 1 and 3. Did anybody remember what the derivative was? I think h prime was, correct me if I'm wrong, but I think it was g of x plus x times g prime. Am I right, you guys? Okay, cool. All right, so unfortunately we had to plug in 1 to these things. But you know what? We don't really have to actually calculate it so much as we just need to know whether it comes out to be positive or negative. Okay, so let's do 1 first. Now from here to here is -3, and then from here to here, I'm going to 1. That's an area question, right? G of 1. So we're going from negative 1 to 1. So -3 plus, what is that? That looks like it's going to be 1 times a half. It's going to be about a fourth. So what's -3 plus a fourth? -2.75. And then here, if we plug in a 1, we get 1 times g prime of 1. Now g prime of 1 is equal to f of 1. So they just want the y value at that point. So what's the y value at that point? I would say it's probably about a half. So let me ask you guys, without simplifying this, but you could do it with a calculator if you wanted to. What's going to happen if you do -2.75 plus a half? Is that going to come out to be positive or negative? I'm pretty sure that's going to come out to be negative, right? If you're only adding a half to this, you're going to end up with a negative. So what that means then is we have a negative slope here. Now I need to find the slope at 3. Okay, so I'm going to go back and plug in 3 here. And here. So now I'm trying to find the slope of h at 3. So g of 3, so that's the area from -1 to 3. So we have this area, as we've said many times, is -3. This area is 3 times 1.5. I'm just going to use my calculator now because that's just kind of getting annoying. 3 times 1.5 cut in half for the area of a triangle is 2.25. And we're adding -3 to that, which gives me a total answer for that piece there, -0.75. Now I need to find 3 times g prime of 3. G prime of 3 is equal to f of 3. In other words, we just want the y value. And that looks like it's about 1.5. Now, 3 times 1.5, whatever it is, it's going to be bigger than 3, right? So if I add that to -0.75, the positive is going to win. So we end up with a positive. So even though I made a little bit of a blunder here and thought the second derivative test was going to be easier, and it actually wasn't. It was inconclusive. This was still a good review because we got to do first derivative. So what would we say about x equals 2? Is that a min or a max? Anybody can chime in. Yep, because we're going from negative to positive. So let me review what we did there on part G before I go any further. So first of all, if I want to tell if it's a min or a max, find the critical value. So I made sure that when I plugged this into the derivative, I got 0, and I did. Then I tried to do second derivative test, but I got 0. When you get 0 on a second derivative test, it means it's inconclusive. So I threw that out, and I went back to first derivative test, which is where you do the slope to the left and right of your critical value, and you just look at the slopes to determine whether it's a min or a max. So to justify our answer, our final answer would be this does not count as a justification, just so you guys know on this one. You actually have to write it. You still want to show all this work, but that does not count as a justification. So what you would do is you would say since h prime changes from negative to positive at x equals 2, this would be a relative min. So that's how you justify that. You still need to show all that work, but this is how you would officially have to write your answer as your final bit. Okay? Yeah. Maybe I did. Oh, dang it. Yeah. Well, so what did you get? So you guys got a, so I'm assuming that when you guys did it, you got a positive? Okay. And that would have saved us a lot of time. Dang it. Sorry. I guess I guess yeah. Oh, poop. That's it, huh? Darn it. Well, good catch. I'm glad I teach such smart kids. That's awesome. Uh, the good thing about my blunder is that we got to see the first derivative test, though, so that's nice. And honestly, you're more likely to use the first derivative test than you are the second, but oh well. But yeah, so it's there. You can use the second derivative. But that's the end of our first FRQ. Now, just so you guys know, I put way more questions in here than you'll actually see. Okay? I'm just trying to cover everything that you typically see with these types of questions. All right? But that covers it for that. Let's take a look at our next one here. Read it for a second. I'm going to call on you, and I'm going to ask you what type of FRQ is this? So like you're taking your AP test and you've got to flip to your notes. Which one are you going to pull out? I'll call on you in a second to share out your answer. Let's try Chris. Chris Ignacio. Which one do you think we would, what kind of FRQ is this? That's okay. Were you here for the first 30? Okay, that's okay. That's why you don't know the answer to my question, because that's something we talked about in the beginning. Um, can somebody tell me what type of FRQ this is? What sheet we would pull out and look at? It is, and you know how you can tell? When you see that guy. When you see that, that's a differential equation one. And sure enough on this thing, let's see. I know they got to have it on here somewhere. No. Oh, okay. It's on another one I made actually. Um, they usually ask for to find that particular solution, and that's the one that's worth like 5 points. So, all right. So you want to get out your differential equation notes that I gave you today, and slap that on top, and we'll start looking at it. Now, this is kind of a weirder one. Um, Usually on these types of questions, they start by giving you the derivative and then they start asking you questions about that. Okay. But this one's weird because they give you the original equation first, and then they ask you to prove that that's the derivative. That's not normal. That's not real common. You might be wondering why I put that in there, because when I was putting together this worksheet, yeah, I want to get all the basic stuff in there, and that's why there's so many problems. But I also want to throw in some of the weirder things you'll see. So in this one, they actually give you the particular solution. So that's why there's no question in here that says find the particular solution. And don't worry, I put another differential equation in this worksheet packet where we do get to do that, practice it today. But for this one, they give us the original one. So the first question is asking us to prove that the derivative of this thing is equal to this. And for that, it's going to be an implicit differential thing. So let me make some working space here for myself. All right. Okay, so I want to find the derivative with respect to x, right, of this thing. All right, so we're just going to take the derivative as we go. So the derivative of 2y cubed is going to be 6y squared. But don't forget that when you take the derivative of a function with respect to a variable that doesn't match the one you're actually finding the derivative of, you need to put a prime next to it. That's how you do implicit differentiation. Continue here. The derivative of that would be -6, but don't forget the y prime. This one is going to be 6x. The derivative of 3x squared is 6x. But notice that this variable does match that, so we don't put the prime in. Continuing, we get -8. And then on the other side, derivative of 12 is 0. Now, the strategy here for these at this point is you want to keep the y primes on one side of the equation and move everything else to the other side. Okay, we haven't done this in a little while, so this will be a good review. Like I said, this type of question is a little bit uncommon, but sometimes they ask you to find the second derivative, in which case this process will come in handy once again. So it's good that we're reviewing. So there's that. Now, the next thing that we're going to do is you want to factor out the y prime. Okay, so some more space here for myself. So notice both of these factors here have a y prime, so I'm going to pull that y prime out. And then the last thing we want to do is divide both sides by this expression here. It's not quite the last thing, but it's pretty close to the last thing. And there's that. Now, just so you guys know, y prime, that's just another way of saying dy dx, right? So we're almost there, but now compare this with this. What else do you think we can do? I mean, assuming we've done everything right, what else can we do here? Because it doesn't still quite look right. I'm not sure if anybody might see it. You're right. And before I do that, by the way, you guys notice I made another boo-boo here? My negative became a positive. So I'm going to go back and fix that really quick. And the reason I caught that is because I was comparing it to the answer, and I noticed they had a -1 on the bottom, but I had a plus. Anyway, so yes, we're going to divide everything by 6. So if you do that, lo and behold, you end up with -x plus 3 on the top and y squared minus 1 on the bottom. And I don't think they're going to care if you switch the top numbers around to get that. It doesn't matter. So we've done it. Okay, so that's an implicit differentiation. And even though this question is weird, on the more common questions, like I said, sometimes they'll ask you to find the second derivative, in which case you're going to follow a similar process. All right, let's move on to another one. How would they grade that, I wonder? Gosh. Honestly, I'm not too sure how they would grade it. My guess is they'd make it worth 2 points, though, and just kind of grade your work along the way. But I haven't seen too many questions like this to be able to know how they would choose to grade it, actually. All right, let's take a look at part B. I've been seeing these questions a little bit more lately. There's 2 of them. Take a look at part B and E. Find where you have a horizontal tangent or a vertical tangent. Now, when they ask if you're having a horizontal tangent, what that means is that the derivative is 0, right? If you have a tangent line that is 0, that means, I'm sorry, if you have a tangent line that's horizontal, that means the slope is 0. So y prime equals 0. If you have a tangent line that is vertical, like let's say this one, your tangent line looks like that, that's where your derivative is undefined. Okay, so keep those things in mind. I've been seeing a lot of those lately. I used to think they were kind of rare, but I've been seeing a little bit more of those lately. So let's take a look at part B. Find any x coordinates where the curve has a horizontal tangent. Now, like we said, that is when the derivative equals 0, right? And the derivative is 3 minus x over y squared minus 1. Now, what part of the fraction do we look at if I'm trying to make the fraction equal 0? Top or bottom? Anybody can? That's correct. So if I want this thing to be equal to 0, so we set the top equal to 0. So we would say we have a horizontal tangent if dy dx equals 0. Therefore, we have a horizontal tangent when the top, 3 minus x, equals 0, which is x equals 3. Boom. And we're done. It's that simple. So we have a horizontal tangent anytime the derivative equals 0, and the derivative equals 0 when the top equals 0. So therefore, we have a horizontal tangent at x equals 3. Nice and simple. Once again, I'm not too sure how they would grade it. My guess is 2 points, 1 point for this explanation, and then another point for getting the correct answer. That would be my guess. All right, let's take a look at part C. Yes. No, they don't do any participation points. So yeah, your explanation would have to be correct. Yeah, for sure. Let's see. Part C, very common question. And that's on your guys' sheet, right? How do you find a tangent line and how do you use it to estimate something? So if you want to flip to that now, look for the thing on differential equations where it says finding the equation of a tangent line and try to follow along with us there. So part C says write an equation for the line tangent to the curve at this point and use that line to approximate the y value in the equation when x equals 1.9. Okay, so here we go. I'm going to make some writing space for me here. All right. So when you're trying to find the equation of a tangent line, you need 3 things. You need a slope, you need an x, and you need a y. Now, the x and y are given to us. That's nice and easy. My slope is going to be plugging the x and y into my derivative equation up there. So I'm going to be plugging in 2 for the x and 3 for the y. So that comes out to be 1 over 8. So my slope is 1/8, and my x and y values are 2 and 3. So I can write my tangent line equation. Now, the one that I give you guys in class looks like this. And they would probably give you full credit for that. I'm pretty sure of it for this part, writing an equation for the line tangent to the curve, because technically that is an equation. However, just to be safe, my advice is, even though this is how I showed it to you guys, and probably in the future, I think I might just teach a little bit differently to avoid this, just add the 3 over here instead. Okay, so now that's a little bit better. It's kind of better to have the y by itself for your tangent line. And a good reason for that is because of what's coming up next. So like I said, this here, you could get maybe 1 point or maybe even 2 points for having that on your paper. A lot of times they give you a point for just finding the slope at that point, and then they'll give you another point for just writing the tangent. So that's a possibility of 2 points. However, it's possible that they might only give you 1 point for just getting the equation. So it's different. I've seen it done different ways. But the next part, we're not done. Use this line to approximate the y value when x equals 1.9. Guys, this is really easy, and don't make it harder than it has to be. Plug in your 1.9 right here and stop. Don't simplify that. Waste of time. That there is your automatic extra point. I guarantee you that alone is worth 1 point. Just plugging it in. You do not have to calculate it. It's a waste of time. You're good. Okay? So it's possible this question would be worth 3 points, but it could also be worth 2, depending on how they want to distribute. All right. Moving on. Determine the concavity at 2, 3. So I'm going to ask a question of you guys out there. How do I find concavity? Second derivative. Very good. So I want to find the second derivative. So let's do that. Let me bring up some writing space again. And we're finding the concavity at 2, 3. So we already have the first derivative. So to find the second derivative, I just need to take the derivative of this. What derivative rule would I apply here to get my derivative? Quotient rule. Very good. So we're going to do low d high, you guess that's the derivative of the top, minus high d low. Be careful here. You guys good with this part here in particular? That's a tricky one. The derivative of the bottom is 2y, but since we're taking the derivative with respect to x, when you take the derivative of that y piece, you do get that y prime in there. Draw a line and square below. Okay, now when we learned this in class, I had you guys actually go through and simplify this expression, and sometimes they might want you to do that. However, that's completely unnecessary here. All you need to do is go through and plug the stuff in that they give you. So I didn't want to do that. Second. We're just going to plug in the numbers that they give us. So for y, I'm going to put, sorry, technical. For the y, we're going to plug in 3. And for x, I'm going to plug in 2. Now, the one thing that's a little bit different here is, what do I plug in for my y prime? Well, we did that earlier. You guys remember we plugged in 3 comma, was it 2 comma 3? Yeah, we plugged in 2 comma 3 up here. Do you guys remember what we got? What did we get when we plugged in 2 comma 3 up here? We got 1/8. So I'm going to replace this y prime with 1/8. Now, if they just wanted to know what the second derivative was at this point, I would just leave it. However, since they're asking us if it's concave up or down, you do need to actually kind of go through the work to figure out if it's positive or negative. So this piece here, that's 9 take away 1 is 8. And 8 times negative 1 is negative 8. Minus, that's 1. And this is 6 over 8. Ugh. 2 times 3 times 1/8 is 6/8. And on the bottom, we have 9 minus 1, which is 8 squared, is 64. Now, the bottom's positive, but what do you guys think about the top? Is that going to come out to be positive or negative? It's kind of obvious, right? Since they're both negative on the top, we have a negative number over a positive, right? So did my second derivative come out to be positive or negative? It came out to be less than 0. Therefore, it's concave down. Now, you need to show all this work, right? But your explanation will be the following. You would say, since the second derivative is less than 0 at the point 2, 3, the function is concave down. I guess we probably shouldn't call it a function. We should say the graph, right? The curve. So this would be your explanation, but you do need to show all that work, okay? Now you guys notice that I didn't say the function. This is a small detail. I doubt, it's like one of these little things. It's like, dang it, hope it doesn't happen. But this is not a function, just so you guys know. Implicit equations are usually not functions. That means that every x value does not necessarily only give one y value. It's a small detail from pre-calculus. So I'm just going to say the curve, because I don't know if it's actually a function or not. But kind of a side point. But there you guys go. All right, part E. Is it possible for this curve to have a vertical tangent at the point where it crosses the y-axis? Okay. So I'm going to ask you guys some questions here. So if the tangent is vertical, what do we know about the slope at that point? Ryan, let me ask you. If we have very good, it's undefined. So if my slope is undefined, how can I find out where the slope is undefined? And I'll ask, that's right, that's where the bottom equals 0, right? So the first thing I would do is I would set the bottom equal to 0 and solve. Now you got to be careful here. If you add the 1 over and take a square root, I still have a lot of my calculus kids forgetting this. You get 2 answers. When you solve by taking a square root, you get 2 answers. It's +1 and -1. So now the question here is it possible for this curve to have a vertical tangent point where it crosses the y-axis? So here's my question to you. We know that this function has vertical tangents at y equals 1 and y equals -1. How can we tell if that's where it's crossing the y-axis? That's kind of a tough question. This is a pre-calculus thing, but any thoughts out there? I'm just opening it up to anybody. How can you tell? We know it's happening at y equals 1 and -1, right? But that doesn't necessarily mean it's on the y-axis. So how can we tell if that's happening on the actual y-axis itself? So let me ask you guys a question then, to be more specific and help you guys out. When you're on the y-axis, you know something. You know that x equals 0, right? So here's the deal. We already know, this is a hard question because we've never done anything like this in class, and it just kind of requires a lot of creativity with your pre-calculus. But we already know that there are 2 places where this function has a vertical tangent. One is when y equals 1, and the other one's where y equals -1. The question is it happening at the y-axis? In other words, at that point, is x equal to 0? So now how can we tell if that's the case? Well, you got it. I should be able to plug that into this equation and it should work. Okay, so let's do 0, 1. If I plug in 0 for x and 1 for y, let's do that. So plugging in 1 for y, I get 2 minus 6 plus, if I plug in 0 here, that's gone. Plug in 0 here, that's gone, equals 12. So I end up with 2 take away 6, which is negative 4, equals 12. Does that point exist on the curve? What's our answer? No, because those aren't equal, right? Let's see if this point exists on our curve. All right, so if I plug in negative 1 here, I get negative 2. If I plug in negative here, it becomes plus 6. And both of those go to 0 again. Here we get positive 4 equals 12. No good. So the answer to our question is no. How would you write this explanation? You would say, there are vertical tangents at y equals, well, I guess we could just put y equals positive and negative 1. But 0, negative 1 and 0, 1 are, I'm kind of running out of screen space, so I'll write it over here, are not on the curve. So our function has vertical tangents at y equals 1 and negative 1, but whenever y equals 1 and negative 1, it's not possible for x to equal 0 because when I plugged it in up there, it didn't work. So there's your explanation. So that was a weird one that requires a little bit of pre-calculus knowledge. But honestly, I have seen this question before. Not very often, but I've seen that type of question before. But as you guys can see, this whole horizontal vertical thing is pretty common. So at least know that setting the top equal to 0 finds horizontal tangents. Setting the bottom equal to 0 finds vertical. So how would they grade this one? My guess is for the second one, if you set the bottom equal to 0 and found y equals 1 and negative 1, that there probably would have been half of the points. They'd probably give you 1 point for that. The other point would probably be for making sure that those points are not on the curve. And that's about it. So that would be my guess. All right, so that's the end of that one. Let's take a look at another one. But it's time for a break. So why don't we take a little 5-minute and just like on the test, you guys, I would encourage you to get up and just stretch your legs, go get a drink of water right now. Trust me, you'll feel better when you come back and sit down and do some more of this stuff. So, but I'll pause here for about 5 minutes and I'll be back at 2:09. All right. Let's go ahead and take a look at part B here. Show that any point with an initial condition that is along the y-axis, where y is greater than 1, creates a relative max for this particular solution. This is very wordy. So let's analyze it a little bit. Show that any point that is along the y-axis. Once again, if I'm on the y-axis, I know something, don't I? I know that x equals 0, right? So basically, if x equals 0 and y is greater than 1, right? How can we be sure that that creates a relative max? Interesting question. All right. Well, let's do that. So we know that if x equals 0, then the slope is 0, correct? So that means that if your slope is equal to 0, then that means it's a critical value, which means that it could be a relative min, or it could be a relative max. Now, how can we tell if it is a relative min or a max? Well, usually what we would do is we would have to do like a first derivative test or something. I'm feeling kind of tempted to do the second derivative test again, but now I'm kind of scared to try it because last time I tried it, it didn't go so well. I'm having some trouble thinking of the first derivative test for this one, because usually with the first derivative test, what we do is we put our critical value on a number line, right? But here's the issue with that. The critical value is I guess we could do the x value is 0, right? And what we want to do is we want to find what is the slope to the left and right of that. Okay, so we already know that at 0, we have a critical value because the slope is 0. And for this, so long as we use any y value that's greater than 1, we can do it. So let's try it out. So let's pick a number less than 0. That would be like -1. And let's pick a number greater than 0, which is +1. All right. So if I were to plug in a -1 here, right, for x, I'm going to get a +2. And remember, y has to be greater than 1. So we're plugging in anything bigger than 1. Now, if you plug in a number bigger than 1 for y here, and you minus 1 from it, it doesn't matter what you get. You're always going to get a positive number. So I have a positive times a positive, which means that anything to the left of 0 is a positive slope. Let's repeat this process then for plugging in an x value that is greater than 0. So if I plug in +1, I get -2. And this piece, y still has to be greater than 1. So that part's still going to be positive. So now I've got a negative times a positive. So over here it's negative. And there you go. There's your relative max. So the question was, prove that for any point along the y-axis where y is greater than 1, you end up with a relative max. And so there's our work that we just did. But now we have to write our explanation. So how would we do that? So we would say that for all points where x equals 0 and y is greater than 1, dy dx equals 0, and the slope goes from positive to negative. I'll write it over here because I'm running out of space. And dy dx, the slope, changes from positive to negative. So there's our explanation. So for all points where x equals 0, that's a fancy way of saying on the y-axis, and y is greater than 1, the slope equals 0. We got that by plugging in the point 0 and something bigger than 1. And the slope goes from positive to negative at that point. So that would mean it has to be a relative max. All right. That was a weird one, but it's good to see weird ones. Let's go ahead and take a look at part C. Now, part C is the one that I want you guys to be pros at. So, you know, we did a week of this a little while ago, and I would just encourage you guys to practice them. If you have your blue books, your FRQ books, or if you just want to Google FRQ questions online, type in FRQs for any year, and they'll always have one where you have to find a particular solution. And I would just practice those, guys. Make sure you get it to the point where you get all 4 points. Because like I said, if you get this one question, you pretty much passed that one FRQ. Okay, so it's and what I like about it is that once you get the process down, it's literally the same for almost every question. So it's just an easy pass. So you don't want to miss that opportunity. All right, so the question was, let's see. Find the particular solution to the given differential equation with this initial condition, 0, 0. All right. Let me get my writing tool back. Okay, so find those steps on your guys' notes there. Step 1. I want you guys to do this with me. I know they're right there on your paper and you guys can read it, but I want to make sure you guys can find those steps. So I'm going to ask you guys to walk me through the steps. What is the first step there? How about, let's do Angelina. What's the first step to finding the particular solution? Do you have those notes? Do you have those notes that we looked at earlier at the beginning, Angelina, or no? Okay. Okay, that's fine. So what I want you guys to do, for the rest of you guys, what I want you to do is I want you to find the notes that you printed out, right, for today, and then find the part on differential equations that says finding a particular solution. The first step says separate the variables, okay? So what that means is I'm going to multiply both sides by dx. So now I've got a dx on the right, and the dx on the left is canceled. And then I'm also going to divide both sides by y minus 1. So on the right side, the y minus 1 is gone, and on the left side, I end up with this. So right there, just multiplying and dividing to separate the y's and the x's, that is 1 point. Okay? All right, the next step is to integrate, and they usually give you a point for doing each integration. So at this point, I'm going to pause, and I'm going to let you guys do the integration, and I'll call on you. So I want somebody to do this side and do this side, and I'll call on you guys. So I'll give you like 2 minutes to work that out. All right, so let me call on some people here to see what you guys got. Who haven't I talked to in a little while? I haven't talked to Thea in a while. Hey, Thea, what did you get for 1 over y minus 1? The integral of that. Good. Now here's the thing. Just so you guys know, there's a pretty nice shortcut for these. A lot of the time when you do this, it's just going to turn into ln of whatever the bottom is. However, you got to be careful because, like, let's say there was a 2 here. If you don't do that u substitution, you're going to miss the fact that there actually ends up being a half in front of that ln. So that's why I still encourage you guys to do the u substitution. But a lot of the times, if the derivative of the inside is just 1, well, your answer is literally just going to be ln of the bottom, so you can save yourself some time. But that only applies if the derivative of the bottom is 1, okay? Let's do the next side there. Juliana, what did you get for the other side? Good. And she remembered her plus c. That's good. So negative x squared plus c. Okay? Now, let's see. That there is 2 points. You get 1 point for doing each side. So 1 point for this side, 1 point for that side. So I'll put plus 2 there, actually. Okay. Okay. The next thing that we need to do is go ahead and start getting the y by itself. So if I want to get this y by itself, you guys, how do I get rid of the ln? What do I do? And I'll let anybody chime in who feels. How about Max? I haven't talked. Oh, go ahead. Was that Ryan? You got it. Good. All right. So we have e ln of y minus 1. Now, we talked about this situation over here a little while ago. That can be rewritten like this. And you don't have to show all these steps, by the way. I'm just doing this for teaching purposes. But that could be rewritten like that. And since e is just a number and c is just some random unknown number, we could rewrite it like this. And so my advice is in the future to skip those steps and basically jump straight from here to here. That's basically it. So there's that. Now this and this cancel, right? So I'm left with the absolute value of y minus 1 equals c times e to the negative x squared. Okay? Let me make some more writing space for myself here. I can clear this all off, actually. Okay, so we had the absolute value of y minus 1 is equal to c e to the negative x squared. Now, when you have an absolute value expression there, what that means is that y minus 1 can be equal to a positive c, or it could be equal to a negative c. And honestly, if you forgot that on this problem, it's not going to really matter. You're going to get the same answer either way. So that's another point, by the way. Just being able to get that y by itself is another point. The next thing I'm going to do is I'm going to plug in my numbers. So we're plugging in 0 for x and 0 for y. So if I plug in 0 for y, I get negative 1. And if I plug in 0 for x, that's going to be e to the 0, which is just 1. So I'm left with negative c here, dividing both sides by negative 1. Oh, wait, sorry, my bad. Back up. That's not a negative. That was a positive c. So that means that c equals negative 1. And the reason I told you that splitting this up doesn't really matter is because if you did the same thing over here, if you plugged in 0, you're going to get negative 1. And plugging in 0 here, you're going to get negative c there. And in that case, well, that's going to give us c equals 1, right? And now you might be thinking, well, which is it? Is it positive 1 or negative 1? Well, it doesn't really matter, because if you plug negative 1 up here, you end up with negative e, right? If you plug in positive 1 here, you still end up with negative e. So here's our final solution. Y minus 1 is equal to negative 1 e to the negative x squared. Now, just so you guys know, they do want that y by itself, so go ahead and add the 1 to the other side. So that wasn't our final answer. This will be our final answer here. So like I said, that last step of getting the y by itself is kind of the hardest part. Now you guys can actually, I did this a little bit different order than I usually do. A lot of times I suggest students to plug in the numbers to find c before they get the y by itself. I did that, and I ended up with an equation that wasn't right. And I found out why. It had to do with the absolute value. But I found out that by getting y by itself first and then plugging in, it kind of avoided that issue. So all I can say is make sure your answer works at the end. If it doesn't, go back and fix something. How do you know if it works? Here's how I knew it works. If you plug in 0, you should get a good answer, right? If you plug in 0 for y and 0 for x, so you're going to end up with negative 1 plus 1, which is 0. And that works. So we're good. If you don't get that initial condition working, then you've done something wrong. However, just remember, if you don't get the y by itself correctly, and I think so long as you just even tried to find c by plugging in the numbers, I think they might even just give you the points for trying to find c. So you can get 4 points right off the bat, pretty straightforward every time. All right, so that's the one I really want you guys to know well, and make a note to yourself if you were kind of confused on that, you feel like you don't have that down. I would spend tomorrow, if you want. I mean, I don't want, or Monday, just kind of going through various old FRQs on the internet and trying ones just like that. Just type in, 2010 FRQ, find the differential equation one, look for the one that says particular solution, work it out, and look up the answer and see if you got it right. Watch the video on YouTube if you didn't get it right. I would just keep practicing until you get it, because I mean, I would hate to have you guys invest all that time and have it not be on this test, but to be honest with you, I would be amazingly surprised if you don't see that on the test, just so you know. All right, so part D. What do you guys think that's going to be? I'll just go ahead and shout out. What do you think that's going to be? What thing on our notes? Yep. Now, we're not sure yet. It's only L'Hopital if it actually turns out where you try to plug it in and you end up with 0 on top and bottom or infinity on the top and bottom. But I'm pretty sure that if you see one on your test, it'll probably be L'Hopital, but don't get too comfortable with that. So let's go ahead and start here. So the first thing you do with L'Hopital, so find it on your notes and try to follow along. But the first thing you do is just do direct substitution. So we're going to plug in 0 here, and we're going to plug in 0 on the bottom. Now, what is f of 0? They tell you. It's 0, right? Now, what's tangent of 0? Oh, dang it. Trig. But, ding, ding, ding. It's okay. You can use your calculator. Don't freak out. So punch it on your calculators. Make sure your calculator's in radians. It turns out that tangent of 0 is 0. So, Ryan, you're correct. That is a L'Hopital. Now, you want to be careful here. You don't want to say equals, right? I still get some people putting that. You want to put this. Yields 0 over 0. So, matter of fact, I'm not even sure if writing this would be a good idea, because technically this expression doesn't exist either, since it equals 0 over 0. So it might not be good to even put equals 0 there. So the best way to write this, just so you guys know, would be writing it like this. Direct sub yields 0 over 0. Okay, therefore, 3 dots for therefore. Remember, save yourself some writing time. Therefore, by L'Hopital, we can say this. The limit as x approaches 0 of f of x over tangent of x squared is equal to the limit as x approaches 0 of the derivative of those things. So now we got to remember to find the derivative of tangent. All right, fun question time. I'm going to ask you, coming at you. Let's do Maya. What's the derivative of tangent? Woohoo! Nice job, dude. All right. So it's secant squared. And we still have an x squared on the inside, so don't forget about that, which means it's actually a chain rule. So I need to multiply by the derivative of the inside now, which is 2x. Okay? Now, we just do direct substitution again. So, f prime of x. What is f prime of 0? Well, we already know that when x equals 0, y equals 0, right? And we know that f prime of x, the derivative, is this thing, right? dy dx, which we know is negative 2x times y minus 1. So if you plug in 0 for both of these, what do you get? I think we get 0 again, don't we? How about on the bottom? If I plug in 0 here, that's 2 times 0. And it doesn't matter what secant equals, because 2 times 0 is 0, and if you multiply 0 times secant, it doesn't matter what it equals, you get 0. So guess what? So we got to, and sometimes that happens where you have to do L'Hopital twice. Okay? So I'm going to repeat that. So now we get to find the derivative of these things. Let me clear some space here. Now, whether or not they're going to have you do L'Hopital twice, I don't know, but it's possible. It's nice we're getting kind of a worst case scenario here in our practice. All right, so now we would say, therefore, by L'Hopital, the limit as x approaches 0 of f prime over 2x secant squared x squared is equal to the limit as x approaches 0 of the derivative of those things. So we have f double prime now over, now we got to do the derivative of this. Now this one kind of, this one's really a pain in the butt. That's a product rule and a double chain rule to find the derivative of that. So I'm going to show my work down here. So there's my first piece, there's my second piece. So I'll take the derivative of the first piece and I'll leave the second piece alone. And then I'm going to leave the first piece alone and take the derivative of the second piece. Okay, now the derivative of the second piece is a double chain rule. because really what we're looking at there is we're looking at a secant function, right, with an x squared inside of it, but that secant function itself is being squared, so we have a function within a function within a function. So the derivative of the outside is going to be putting the 2 in the front and taking 1 off the power, which just leaves us with secant instead of secant squared. Then we do the derivative of the inside, the secant. The derivative of secant is secant tangent. So it's going to be secant x squared, tangent x squared. And I know this is looking nasty, you guys. And think about how your brains are feeling right now. Like, I know how I'm feeling. I'm looking at this type of question. I'm thinking, okay, I'm done. This isn't worth it. And you're going to feel like that probably on the test too. But, well, maybe not. It's only 45 minutes. But hang in there. This is where they test your perseverance, right? So there's that. And then we do the derivative of the inside part, the yolk, and that's 2x. So there's a lot going on there. So that whole thing down there, I'm just going to draw an arrow. And you guys can do that too, by the way. Just draw an arrow there so you don't have to rewrite or anything, but that's your second derivative. Now let's do the top, though. We haven't found the second derivative yet of our function. We know that the first derivative is, we know the first derivative of our function is this, right? But we haven't found the second derivative yet. So we need to do that. And this here is a implicit product rule. Okay, we have a y, so that's implicit. And we have two things being multiplied. So I'm going to put an arrow, and I'm going to write my second derivative here. Okay, so here's my first piece, and here's my second piece. It's going to be blank times blank plus blank times blank. So we have the derivative of the first piece times the second piece. And then we have the first piece times the derivative of the second piece. Now the derivative of the second piece there is y prime, right? But instead of y prime, I'll write it underneath there, but y prime is just this whole thing, right? Isn't this just y prime? So I'm just going to put that in there now. That. Okay. And once again, you can just circle this if you want to and draw an arrow up to there because that's what that is. Now let's go ahead and plug in our 0 and see what we get. And remember, when we're plugging in x equals 0, you're also plugging in 0 for y because that's our initial condition. If x equals 0, then y equals 0. So let's keep going here. So if you plug in 0 for secant, what do you get? I think, remember, secant is just the reciprocal of cosine. So first of all, yeah, you're right. So since secant is the reciprocal of cosine, cosine of 0 is 1, and the reciprocal of 1 is 1. So secant of 0 is 1, and we're squaring it, but 1 squared is still 1, times 2 is 2. So we have, I'm going to put my answer here, 2 plus 2 times 0. Guys, look here. 2 times 0 times this, times this, times this, times this. It doesn't matter what any of this is. Since there's a 0 here, that whole thing dies because you're multiplying the whole thing by 0. So the bottom is 2. So even though that looked really ugly, when you go to plug it in, everything goes away. So that's pretty sweet. Let's do the top. Now, same thing on the for the top here, we're going to be plugging 0 in to the bottom here. So if I plug in 0 for the y here, I get negative 2 times negative 1, which is 2, plus, now let's do it here. Well, we're multiplying by 0 again, so that whole thing goes away. So I'm left with 2 over 2, which equals 1. We're done. Whew. That was a crazy problem. But what I like about this problem is that you get a lot of practice with derivatives. You also get to see the L'Hopital to the extreme. So that was a good L'Hopital prep question. All right. Yeah. Mm-hmm. Oh, yeah. You're right. So what Juliana was saying was that instead of finding f double prime the way I did, by taking the original derivative equation I had, she just took the particular solution she found in part C and found the derivative of that instead, which is good. That will work, Juliana. The only danger to that is if you got part C wrong, that's going to cause you to get part D wrong too. However, I think that I'm pretty sure I've heard that on these tests that if you got something wrong in one part and you use that wrong thing, but you use it in a correct way later on, they'll work with the wrong thing you use. So even if you got part C wrong, I think they'd still give it to you. So, but yeah, it's pretty smart. I like it. Good job, Juliana. All right, so that's the end of that one. We're at 2:43, so we got about 15 more minutes. We're getting right about where I wanted to be. It's just that I don't think we're going to finish this whole question here. I really wanted to get through this one at least. And after that, I had other questions of just a little bit more rare type of things that you'll see. Like the one we're about ready to do is a table question. So that's something you want to be ready for. The other ones are like piecewise functions. You guys have noticed those pop up every once in a while. And this one here is all about related rates. So we probably will not even get to finish this one by 3 o'clock. But I'm going to stop at 3 just because I don't want to take the rest of you guys' afternoon. But I'm not going to stop at 3. I'm going to stop the Zoom, but I'll keep recording it and then I'll upload the whole thing later and you guys can watch the rest on your free time, okay? I just don't want you guys to feel like you have to stay longer than 3 because it's been a while. But I'm going to go ahead and go as far as I can in the last 15 minutes that we have here. All right, so this is a table question, right? So at this point, we recognize what kind of FRQ this is, so we would want to pull out the table notes, the table question notes from the notes that we printed out earlier. Let's get started. All right, the velocity of a particle moving along the x-axis is modeled by a differentiable function, v, where the position x is measured in meters, units are good to know, and t is measured in seconds. Selected values of v are given in the table above. So v represents the velocity of that function. And then they tell us the position of the particle is x equals 7 at t equals 0. So there's kind of like your initial condition that you might want to be aware of. Okay. Let's do some table questions here. So part A, I mean. Estimate the acceleration of the particle at t equals 36 seconds. Show the computations that lead to your answer and indicate the units of measure. So I shall ask a question. How do we estimate the acceleration? How do we estimate the acceleration? Let me ask Max. Max, how do we estimate the acceleration? I think we got a chat response there. Hold on a minute. Shall look at it. All right, Max says we would find the rate of change of the values in the table. That's correct. Let me hide the table here. Okay. So now, guys, notice something. They've told me what the position is. The position is x. They've told me what the velocity is. It's v. Did they give us an equation or a letter to represent acceleration? The answer is no. So, but I want to use a letter to represent acceleration. But if I'm going to create a new letter, I need to define it. You guys know that. We've talked about it many times. So I'm going to start by writing let A equal acceleration. Okay, so I want to define that right up front. Okay, so now it says estimate the acceleration of the particle. Well, the acceleration of the particle at 36 seconds is equal to the derivative of the velocity at 36 seconds. Now, we don't know what the derivative of v is because they didn't tell us, but we can estimate the derivative of v at 36 by picking the two values that are closest to t equals 36, and that would be at between 32 and 40 seconds. So we can estimate the instantaneous rate of change of v by finding the average rate of change from 40 to 32. And at that point, v of 40, very easy to tell, is just 7. V of 32 is -4. And then we have, I think I wrote the bottom funny. It's supposed to be 40 minus 32. 40 minus 32 on the bottom gives me 8. So I end up with 11 over 8. Now, we're not done, though. They want us to show the computations. We did that. That's good. And then they want us to indicate the units. All right. Now, here's how you can tell the units. Look at the top. What are the units of v? The units of the top, v, is meters per second. What are the units of the bottom? 40 and 32? Those are seconds. So we have meters per second on the top, and we have seconds on the bottom. That's good enough. Now, if you wanted to get fancy, you could just say that's meters per second squared if you wanted to. Okay, but that's good enough. So we've got our units all set up there. All right, so that's part A. Let's move on. Part B. Is there a value c on the interval 8 to 25 for which b prime of c equals -13 over 17? Explain your reasoning. So I'm going to ask somebody a question here. My question is, before I call on you, it's going to be, what do we do to answer that question? What is there's a main like little red flag that tells us what type of question this is. So Brandon, what do you think that is? What are they really asking me to use here? Not quite what I'm looking for. Not quite what I'm looking for. Let me open it up to the class. Does anybody know what thing on our notes maybe be a better way to ask the question? What kind of strategy on our notes are we going to apply to answer this question? Close, but no. Here's what it is. It's mean value theorem. So how do I know it's the mean value theorem? Look at the function they gave us. It's v, right? Now, if they were asking you, like on part C here, look at part C. Is there a value x on this interval where v is 0? That's IVT. But if they're asking you about the derivative of v, that's MVT, the mean value theorem. Okay, so this is a mean value theorem question. Okay, and so we're going to use the two numbers that they give us there. So here we go. My suggestion to you guys is the answer is always going to be yes. They're not going to give you a no. It's pretty rare. The only time this would ever be a no statement is if it turns out that like if they ask the question differently, like if they were to say, can we use the MVT? Well, then you could say no, because if it's not differentiable, then you can't use the MVT, right? But it is. So the answer is going to be yes. So just go ahead and start off that way. We're going to say yes, since V is continuous on the interval 8 to 25, and differentiable on 825, there is a C such that, and here's where we get to do the math. So I'm going to draw me a box. um, v of 25 minus v of 8 over 25 minus 8 is equal to, and when you're all done, you should end up with that negative 13 over 17. If you don't, you probably did something wrong, because like I said, they're not going to give you one where it doesn't work, because when the mean value theorem fails, it doesn't mean the thing doesn't exist. It just means you can't be sure. And they don't usually ask questions like that. So let's do it. So v of 25 is negative 8, and v of 8 is 5. 25 take away 8 is 17. And so we end up with negative 13 over 17. And I left something off here. Sorry. This is important to have, actually. So v prime of c. So yes, since v is continuous and differentiable on the interval, there is a c such that the f prime of c is equal to negative 13 over 17. And all that means is that, if you guys forgot what mean value theorem is, you don't need to know this really for the problem, just to help you kind of understand what we did. We're going from 8 to 25, right? And we're finding the average slope on that interval. The mean value theorem just guarantees that somewhere along that curve, the instantaneous rate of change is equal to the mean change. In other words, the tangent line is parallel to the secant line. But anyway, you don't need to know that for the problem, what I've written necessary. All right, let's move on to the next one there. Got about 5 minutes remaining. Is there a value c on the interval from 8 to 25 for which the particle's velocity is 0? Explain your reasoning. So, that one we said was an IVT, because instead of asking about the derivative of v, it's just asking you about v itself. So, let's do that. So, let's take a look. As I'm going from 8 to 25, look at your velocity values. Was the velocity ever equal to 0? What do you guys think? Anybody can chime in. Yeah. And we know that because it goes from what to what? You're right. It goes from positive 5 to negative 8. So, but the IVT only works if this thing is continuous, right? And since it's differentiable, it's continuous. So here's how we'll answer that. We'll say, yes, since v is continuous, we don't need to say differentiable. You can, but it's not necessary. Since v is continuous and goes from 5 to negative 8 on the interval 825, there is a c such that v of c equals 0. Okay? Okay, part D. We're making pretty good time here. Oh, so there's a lot of questions. All right. Part D. For the intervals 0 to 40, must the particle change direction in any of the subintervals indicated by the data in the table? If so, identify the subintervals and explain your reasoning. If not, explain why not. So for this one, instead of me doing it, I'm just going to open it up to you guys. Would somebody like to tell me their answer to that? Does the particle change direction? And if so, on what interval does it change its direction, and how do you know? And you don't have to get fancy. You could just kind of explain it loosely to me. Very good. And by that same reasoning, it also changes where? That's right. So from the interval from 8 to 20, the velocity goes from positive 5 to negative 10. That means that the object changed direction, because velocity tells you not just how fast something's going, but it also tells you the direction. So it goes from moving right on the x-axis to moving left on the x-axis. That's a change in direction. Same thing over here on the interval from 32 to 40, the velocity changes from negative to positive. So how would I write that? I would say that the particle changes direction on the following intervals, 8 to 20 and 32 to 40, since v prime changes, no, sorry, my bad, back up, not v prime, velocity, not v prime. Since v changes signs on those intervals. And that's how you'd write that. Okay? So the particle changes direction on those intervals because v changes signs on those intervals. That's it. All right. Let's squeeze in one more question before I end our Zoom chat, and that'll be it for the day. And then, like I said, I'll upload me going through the rest of the questions for you guys to look at maybe tomorrow or Monday if you feel like studying some more. I'll try to have it up by tonight, though, if you guys want to study some more tonight. Okay, E. Using the correct units, explain the meaning of this integral of v of t from 20 to 40, and then use a trapezoidal sum with the 3 subintervals indicated by the data in the table to approximate it. So they want us to do a trapezoidal sum and explain the meaning of it in the context of the problem and using the correct unit. So find it and interpret it, basically, is what they're asking us to do. And they want a trapezoidal sum, so let's get a table going here. Not a black one. Let's do a white one. Okay, so trapezoidal sum, and you got to pay attention to those intervals. I think it said we're going from 20 to 40, right? So we are not using this at all. So that's kind of important to pay attention to. So for a trapezoidal sum, we go from here to here, that's 5. From here to here, that is 7. And then from here to here, that is 8. Okay? So the integral from 20 to 40 of this v function is approximately equal to, because you got to remember, Riemann sums are only estimates, they're not exact integral area values, is approximately equal to the following. So we do a sum of trapezoids here, basically. The area of a trapezoid is 1/2 times the height, so my first height is 5, times the sum of the bases. So negative 10 and negative 8 is negative 18. Plus, and then we just repeat. 1/2 times the height times the sum of the bases. And one more, plus 1/2 times the height times the sum of the bases. I am not going to take the time to simplify that. That is my answer. Okay? Now, I've got a good question for you guys. What are the units? In other words, what is this? Meters, meters per second, meters squared, meter seconds. What are the units of this expression? Remember, I am integrating the v. V has units of meters per second. What did we say happens when you integrate an expression? What happens? Say that again. So you're close. Here's the deal. What are the units for v? The units for v are meters per second, right? But since we're integrating, we multiply a time factor. Those cancel. So what are the units? Just meters. Okay? So when you integrate, you multiply a time factor. When you find a derivative, you divide a time factor. Okay? So this one is just meters. But we're not done. They actually want us to interpret this in the context of the problem. So remember, in an interpretation, you need three things. You need your input units, which are seconds. You need your output units, which are meters, and the context of the problem. What's the context of the problem? What are we talking about in this word problem? What's going on? The problem is talking at the context, or what the problem is talking about. It's talking about a particle moving along the x-axis. So what this means is that on the time interval from 20 to 40, my object traveled that many meters. Now I didn't figure out my answer to that, but we could say on the time interval of 20 to 40 seconds, so there's my input units, the particle traveled this many meters. And notice I'm just putting it traveled that many meters because I didn't actually simplify the basic math to get a number. You could just draw an arrow with it to the expression if you want to. That's it. So I think I'll stop our share there. I'll let you guys take a good long break. And I'll jump on finishing this recording and upload the rest of it tonight. And in case you guys forgot, I'll be at the school on Monday, 10:30 to 11:30, handing out notebooks if any of you guys want them. But other than that, I'll check in with you guys maybe tomorrow. Make sure you guys got your e-tickets, and then I'll check in with you guys again on Tuesday morning just to kind of give you one last hurrah, go for it for your exam, okay? But anyway, I think I'll leave it at that, and we'll talk to you guys later, okay? Hit me up on Remind if you guys got any questions. I'll be glad to chat with you. Have a good one.